So I saw a lot of people in the comments on my previous videos asking if you can use ControlNet with the recently released Flux models. Well, now you can. Not too long ago, X Labs released 3 ControlNet models for Flux 1 Dev. We have a depth model, a canny model, and a head model. I'm not sure when we are going to see other ControlNet models such as OpenPose, but I'll make sure to keep an eye out for that. Until then, let's take a look at what we got over here. I went ahead and generated a couple of images using the 3 ControlNet models, and here you can see the results. So first of all, we have a woman sitting on one knee holding 2 pistols in her hands with a white background. And over here you can see how the ControlNet reacted to that image. The canny and head models did a pretty good job at copying the pose. For some reason the depth ControlNet didn't get the pose 100% right, but all of these 3 images look pretty great. Moving on to the next image, over here we can see a portrait of a man holding his jacket on his back. And looking at the ControlNet results, we can see that all of them did a pretty good job at copying the pose. All of these images look very cinematic, and you can definitely tell that they were generated using Flux due to how realistic and high quality they are. And moving on to the last picture, we can see here a very picturesque alleyway in an old Italian town. And again, all of the 3 models did a pretty good job at copying the overall structure and composition of the image. For some reason, the canny model also added 2 people in the frame, even though I didn't ask it to do that, but overall they all look pretty great. So now let's take a look at how to download all of these ControlNets for Flux. First of all, if you go to the link in the description, it will bring you to this GitHub page, and over here you can see that the first thing we have to do is go into our comfyui/custom nodes folder, and then just go ahead and copy this URL over here. Do not copy 3 and main, just the beginning of the URL. So just hit Ctrl+C to copy, and then go ahead and open your comfyui folder. Over here we can see custom nodes. In this bar just type cmd. This open a command prompt, so now all you have to do is type git clone and paste the link and click enter. This will install the necessary files. So after you've done that, over here you can see that it generated this folder called FLUX ControlNet. Just double click it, and over here you see this Python script called setup. Double click it to run it. This will install some additional files, and after the installation is over, you can move on to the next step. So after that, the next thing you need to do is just go ahead and run this run NVIDIA GPU. This will start Comfy, and you just have to let it run once and then close it. So after you've done that, go ahead to the next link in the description, and this will bring you to this page. Over here you need to download the models. So you can see over here we have Flux Canny ControlNet v3, we also have Depth ControlNet v3 and Head ControlNet v3. Just download all of these files, hit download, and just go into your comfyui folder, go into models, and over here you can see this new folder called X Labs and ControlNets. As you can see, I've already downloaded all of these 3 files, but all you have to do is just click this button for all of these 3 and just click save. So after you've done that, you can go ahead and open comfyui. So now that we are in comfyui, I hope you already have the manager installed. If not, you can check out my other video where I showed you how to download comfyui, the manager, and also how to install the Flux models. So just go ahead and click on manager, custom nodes manager, and in the search bar just search for ControlNet auxiliary. And here you should have a download button. Just click download, wait for it to download, and then restart the application. So to restart it, you just have to press this red button over here that says restart and wait for it. Now this step is not necessary, but it will save you some time. So if you go to the next link in the description, you can see that we are here on a GitHub page. On the KJ nodes page, all you have to do is just click on code over here and copy this URL. And over here you can see it says to clone this repository in the custom nodes folder. So just open the custom nodes folder in your comfyui installation. Over here type cmd, and type git clone and paste the link and just hit enter. This will install a new custom node. And the next thing you need to do is go ahead and if you have the portable version of comfyui, just copy this whole command over here and go back into the comfyui Windows portable folder. Just type cmd and just paste the the command and hit enter. And after that you're done. And now we can go back into comfyui and run the ControlNet models. So now that we are in comfyui, you need a workflow in order to run these control nets. So if you go back to this website, you can click over here on workflows and just click download on either one of these workflows. I'm gonna choose the depth workflow. Just save it wherever you want. And then go back into Comfy and click load over here. And just select the workflow you just downloaded. So this has opened up this quite messy workflow. If you see any red squares over here, all you have to do is go to the manager and click update all and restart the comfyui in order to clear up these red error messages. So now that we've loaded the workflow, the first thing you need to do is go ahead and click over here on choose file to upload. This is the file we're going to use as a reference for the position. And the next thing you need to look out for is over here you can see load FLUX ControlNet. Make sure that you have the FLUX dev FP8 selected. And over here in ControlNet path, go ahead and choose the FLUX depth ControlNet. The next thing you need to do is over here you can see this block called dual clip loader. Make sure that you have clip 1 selected, and over here select either FP8 or FP16 safe tensors. And another thing that you need to look out for, otherwise it's going to give you an error, is make sure that here in the load diffusion model you have the FLUX1 dev FP8 selected. Make sure you don't select the FLUX Chanel version because that won't work. And over here you can select either one of these two options. So over here you can see this block called apply FLUX ControlNet. This is going to determine how much the ControlNet is going to affect the final generation. Over here in the strength section you can choose something from let's say between 0.5 all the way up to 1 in order to determine how much the ControlNet will affect the image. I usually leave it on something like 0.7. This will give you generally decent results. Over here you can see the Midas depth map. This is actually the preprocessor which will create the depth map that is going to be used in the image generation. And over here in the preview image node you will be able to see the depth map that it generated. Over here we have the prompt. This is the positive prompt. I'm just gonna paste in a quick prompt right over here, get rid of this one. And over here you can see this is the negative prompt. So just type whatever you don't want to see in the image. Let's say bad lighting, unreal, low quality, and we're just gonna leave it like that. Over here you can see this empty latent image. Here you have to select what size you want the image to have. So in terms of width, I'm just gonna leave it like that, and for height, I'm just gonna drop it down to let's say 576. Here you have the control after generate. This is by default set to fixed. You should set it to randomize if you want the future generations to look different from the previous one, otherwise they are all going to look essentially the same. Another thing that you have to look out for, make sure that the load VIE is set to AE safe tensors. And after you've done all of that, you can just go ahead and click Q prompt. As you can see, it generated the depth map for the image, and now it's using the diffusion models in order to generate the final image. This usually takes quite a while, especially the first time you run the model, because first of all it needs to load the model into the RAM, and that usually takes quite a lot of time. So I'm just gonna pause the video right here and come back when the image has been generated. Now, as you can see, the resulting image looks very stretched, and that's because over here in the empty latent image, I selected the width to be at 1024 and the height to be at only 576. But if you look at the input image, you can notice that it is actually a square. So if you remember the optional step that I mentioned earlier, this one actually downloads a couple of nodes that are very useful. First one would be the get image size and count. What this thing does is, if you connect this dot right over, if you connect this right over here to the input image, and then you go ahead to the empty latent image, just hit right click, convert, and convert the input, and do that again to convert both width and height. All you have to do is drag these right over here, and now this will automatically take the width and height of the input image and set them by default in the latent image sampler. So if we hit qprompt again, you can see that the resulting image will be a square and will have the exact same size as the input image. So that's one useful trick that you could use if you do not want to have to type the image size every single time. And as you can see, the resulting image no longer looks stretched out, it is actually a perfect square. Now, to take a look at the other ControlNet models, I've made my own little workflow to make things a bit more efficient. If you look up here, you can see that only the head soft edge lines is activated. You can activate the other ControlNet model simply by clicking Ctrl B, and as you can see, now it is active. And we should also click Ctrl B to deactivate the previous ControlNet that we had selected. So now that this depth map is selected, go ahead and drag the image over here into the Apply FLUX ControlNet image section. And you should also drag this into the preview section so that we can see the depth map preview. And another very important step is go ahead and change the ControlNet path to the depth model. And if you take a look over here, this is what I've talked about earlier. This will get the image size automatically, but if the image that you are using as an input is very large, let's say, I don't know, 3000 by 2000, and you connect this, it will automatically pick up the very large resolution and your generation time will increase by a lot. So in that case, it is better to use an empty latent image and set the height and width to whatever you think your graphics card can handle. But if you take a look at this image right over here, we have a man making a punching pose. It looks very dynamic. This picture is actually only 800 by 1200, so we can go ahead and activate these two right over here and deactivate this block. And just drag the latent here in the latent image section. Now let's change the prompt real quick. I don't know, let's say ninja performing a very dynamic punch. And let's increase the ControlNet strength right over here. Let's put it to something like 0.65. Make sure the control after generate is set to random, and let's just click qprompt and see what we get. As you can see, it generated the depth map perfectly. And as you can see, the resulting image doesn't look perfect, but it looks good enough. At least it followed the depth map. So now let's take a look at how the canny edge would look. So just hit Ctrl B to select this one and Ctrl B again to deactivate the Midas depth map. go ahead and drag the image button right over here and do that again to have the image preview activated. And very important, don't forget to change from depth map to canny. And let's go ahead and click QPrompt. As you can see, it generated the canny image over here. The lines aren't really perfect. It hasn't really selected all of the outlines. So to change that, you have a couple of values over here. If these values are lower, then this means that the selection will be more detailed. So you will definitely see more lines in there. I'm just gonna hit QPrompt again so you can see what it does. As you can see, now the canny selection looks a bit more detailed, and the more detail you want to have in the canny map, the lower these values have to go. The result isn't super accurate, so I think I'm gonna go ahead and lower these values so that we have a more detailed canny edge selection. So as you can see, it added a lot of detail to the image, to the selection. So let's go ahead and see what it generates. Okay, so it seems like the canny ControlNet doesn't like this input image very much, because as you can see, it generated a very random, strange image. So let's go ahead and deactivate it and see what the head soft edge ControlNet looks like. Again, all you have to do is drag this right over here and also drag it into the input image to see the pre-processed selection. And don't forget to switch to the FLUX head ControlNet and then just click QPrompt. Now it gave me a weird error and I couldn't really understand why until I looked at the resolution over here. As you can see, this number is huge. I don't know how it got there, so I'm just gonna lower the number to 1024. And now it should work just fine. And as you can see, the head ControlNet does kind of like a more detailed outline of the input image. So let's see how this reflects in the resulting generation. Okay, so it generated this very strange image, but if you take a closer look, you can see that it actually followed the ControlNet. At least we have a guy punching error right over here, just like we have the input image. I tested a more simplistic image. You can see it's simply a woman sitting on a bench in the park. And as for the prompt, I just typed a beautiful girl sitting on a bench in the park at night. And this is the head map that is generated, and over here you can see the result. As you can see, it followed the input pretty closely, even though the image quality is not really the best. So let's go ahead and see how this image would work with, let's say, the depth map. Make sure you don't forget to select the FLUX depth ControlNet and just click QPrompt. So as you can see, it generated the depth map, pretty good, pretty accurate, even though it's not very detailed, but let's see how it handles it. And this is the result. Looks pretty good, even though her hand kind of like disappears over here. But overall it looks pretty decent. It followed the prompt pretty closely, so let's go ahead and see how the canny edge ControlNet works. I might actually raise these values a little bit because I feel like it's going to have quite an easy time detecting the edges in this image. So let's just go ahead and connect the image right over here and to the preview. And I'm just gonna change the canny ControlNet over here and just click QPrompt. So as you can see, it generated a very detailed canny map. I think it's a little bit too detailed, so I might go ahead and raise these values a little bit to get less detail in the edges. Maybe a little higher. And this is the result with the very detailed canny edge selection. It looks very weird. So I think I'm gonna raise these values even further and click Q prompt to see what it comes up with. And yes, this looks like a better canny edge selection map, so let's go ahead and wait and see what the final image is going to look like. And this is the result. It looks a bit weird, but it definitely looks better than before. So as a final test, I'm gonna go ahead and try a different image and see how it works. So I found this picture of a guy posing for a photo shoot, and for the prompt I just typed a professional portrait of a young man posing for a photo shoot. So let's see how it looks. As you can see, the canny edge selection isn't really that great. It might need a little bit more detail, so I can go ahead and lower these values a little bit. But let's see what the image will look like. And this actually looks pretty good. As you can see, it followed the ControlNet and the pose quite well, even though the edge selection wasn't very detailed. So that's it. I'm sure that with some more fine-tuning and better prompts you can get results much better than what I got. But that's essentially it. I hope you found this video helpful, and let me know what you would like to see next.